Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8. We would like to present about full projectiles. I will introduce our group member first. I will start with myself, AINA SYAUQINA, NURUL AINA, INTAN WAFFA, and lastly we have HANI BALQIS. So, let's start our presentation.
What is projectile? Projectile is fundamental field in physics involving the motion of object in space influenced by gravity and air resistance. It involves analyzing the trajectory of an object considering both horizontal and vertical components. This motion follows predictable law governed by classical mechanics involving the kinematics and dynamics. Key concepts like range, maximum height, time of flight, and trajectory shapes are essential in characterizing the projectile path. Application of projectile motion range from spot to complex scenario like ballistic trajectory. The principle of full projectile motions are found in physics education and applied in fields like engineering, ballistics, and astronomy.
So now, I will explain to you about the discussion of the case our group chose, which is water rocket. A water rocket is a type of rocket that uses water as its reaction mass, propelled by pressurized air. Typically, it consists of a plastic bottle partially filled with water and then pressurized with air through the pump. Then, the pressure builds up sufficiently. The rocket is launched by the releasing a valve or opening the bottle's nozzle. The pressurized air will force the water out of the bottle, creating a thrust that propels the rocket upwards. Our scenario in this case will start with filling up rocket with water, preparing for its launching. Then, the rocket is put on the launcher and start pumping it. The rocket will launching at 20 meters per second at 45 degrees to the horizontal. After some time, the rocket will reach its maximum height, and then afterward, the rocket will eventually fall to the ground within 5 seconds.
Based on the scenario, we can find the maximum height obtained by the rocket. First, we need to sketch and take out all the information that have been given. And for find the maximum height, we can use formula of v square equal to u square minus 2gs and substitute all the information that have given and calculate, and the final answer will get 10.20 meter. Next, after we get the maximum height, we can also calculate time taken for the rocket to reach the maximum height. To calculate the time, we can use the formula of Sy equal to ut minus 1 over 2 gt square. U we can substitute with the ux, which is u cos theta, that we have been calculate the value of it is 14.14. And then we substitute into the formula, and the final answer we get 2.89 seconds. Moreover, we can also calculate total distance of the rocket from starting point until it lands. So to find distance of the rocket, we can use the formula of Sx equal to uxt, which is the value of 14.14, and the time that we have calculated for the second question, which is 2.98, and the final answer we will get is 40.86 meter. And for the last calculation that we can calculate is the speed and direction of the rocket after 1.5 seconds. So for the speed, we can use the formula of square root of vx square plus vy square, and then we substitute all the value that have been calculated, and the final answer will get 14.15 meter per second. And for the direction, we can use the formula of theta equal to vy over vx, and we substitute all the information that have been calculated, and the final answer of the direction is 2.27 upward.
Okay guys, we're going to talk about a DIY water bottle rocket. It's super simple. All you need is a 1 liter or 2 liter empty bottle of, it could have been soda, it could have been water, whatever it is. It's a mystery what this is because I've taken the label off. I've taken the cap off, and you're going to want to take the little plastic ring that goes around the outside off. You can just snip it off with scissors. And then the sky's really the limit. This is all you need to make a rocket. You're going to fill it with about, like about a third with water, and it'll launch like this. So the bottom of your rocket, or the bottom of your bottle will be the top of your rocket. We'll take a look at that in a little bit. But to decorate my rocket, I like to use some construction paper. A couple pieces, one so you can wrap a piece around the outside to decorate, another to create nose cones. I pre-cut some foam board for fins. This is easy. You just really want to make sure that they're the length of your bottle. Remember, the skinny part should go up towards the top of your rocket, bottom of your bottle, thick part down towards where the nozzle is. And then my favorite part is stickers. We've got happy face stickers, cat stickers, adventure stickers. I've even got some rhinestones. Make the water bottle rocket your own. You can color on the construction paper, you can add cutouts. Well, let me show you what I do. So for these fins, the first thing I want to do is I'm going to create some stripes with some colorful tape. You could color on the fins. You could also put stickers on the fins. Maybe I should do that. But first thing, I'm going to put some stripes. Probably about 3 stripes a fin. Now, something else you could do, if you have pine wood derby decals at home or stickers, you could use those to decorate your rocket. That could be pretty cool. If you have all kinds of colorful duct tape, you could cover the water bottle with those. So I've created some stripes on this fin here, and I'm going to repeat that process with my other 2 fins. Now let's make your nose cone. So you really just need a circle of construction paper with a wedge cut out, looks like Pac-Man, and then you, to the size that you want it, you can ensure you're making the right size nose cone. So I like a really pointy nose cone. That's pretty close. I'm going to overlap it just a little more. And then I think this is the ticket. Your water bottle rocket is going to get wet because of the water, so I like to cover the whole thing with tape. So first I'm taping it in its cone shape, like we talked about. I'm just gonna hold it in place. And now the tape wildness begins. I'm covering this. Okay, so I finished reinforcing my cone with purple tape, and I finished lining the fins with some purple lines. Got a little more decoration to go, but next I'm gonna grab my hot glue gun and attach all of these to the water bottle. Glue your large rectangle of construction paper on the bottle. Then, glue on your fins. Keep in mind, the top of your rocket is the bottom of your bottle. Lastly, glue on your nose cone. And then, I'm decorating with stickers. Okay, so I decorated my rocket with some stickers. Now let's talk about how you launch it. You're going to fill it up about a third or a half with water, and then you're going to flip it over onto this little nozzle on your launch pad. Push it down real tight. Of course, there's going to be some water spillage. That is okay. Make sure not to look directly over the water bottle rocket because it could launch at any point. You know what? I'll just show you.
So, in our conclusion, we conclude that an object with an initial velocity is propelled at an angle to the horizontal in a full projectile motion. When the object is affected by gravity, it travels in curved manner. Both horizontal and vertical components can be identified in the action. A parabolic trajectory results from the vertical motion being impacted by gravity, while the horizontal motion remains constant and unaffected by it. Before returning to the ground, the missile reached its greatest height at the trajectory's highest point. The equations of motion can be used to determine the time of flight, maximum height, range, and velocity at any given moment in time.